Hello everyone, my name is Savannah Coleman and today we are going to be calculating the speed of light with a microwave. James Clerk Maxwell classified light as an electromagnetic wave. This is when a magnetic field and electric field move perpendicular and sinusoidal to each other. Both fields are also perpendicular to the direction of motion, making it a transverse wave. This diagram will give the general characteristics of a wave. These red circles represent the crests of a wave, which is the maximum height in the positive direction. These blue circles represent the troughs of the wave, which is the maximum height in the negative direction. These green lines represent the amplitude of the wave, which is the maximum height in either direction. This purple bracket represents one wavelength, which can be described as crest to crest or trough to trough. First, we're going to talk about the relationship between the speed of light and electric and magnetic fields. The speed of light is equal to the ratio of the electric field to the magnetic field. In this example, we are given the magnetic field of 1.5 Tesla and asked to find the electric field. If we plug in the numbers that we are given, this gives us an electric field of 4.5 times 10 to the 8th volts per meter. We just related the speed of light to electric and magnetic fields, but it can also be related to the product of the wavelength and frequency. In this experiment, the frequency will be given by the microwave, and the wavelength will be determined after warming the material in the microwave. The frequency of my microwave at home is 2,450 megahertz, and this is the frequency that will be used in the calculations. It then came time to determine the wavelength. In order to use the microwave to determine wavelength, all rotating parts of the microwave had to be removed, including the plate and everything below it. The other materials used in this experiment was a tape measure, peanut butter, and a plate. To conduct this experiment, peanut butter was smeared on a plate and then warmed in the microwave until the peanut butter melted, which was about 30 seconds. The distance between each circle was then measured, and this is half a wavelength, which was around 5 centimeters, meaning one wavelength was 10 centimeters or a tenth of a meter. We found the frequency on the microwave to be 2,450 megahertz and the wavelength to be a tenth of a meter. We can then use this equation from earlier relating the speed of light to the product of frequency and wavelength, and this gives us an experimental speed of light of 2.45 times 10 to the 8th meters per second. We can now calculate percent error. The experimental speed of light is 2.45 times 10 to the 8 meters per second. The theoretical speed of light is 3 times 10 to the 8th meters per second. We can use these values to calculate the percent error, giving us a value of 18.3%. This percent error is relatively low, but it is not perfect. It is also low enough to say that the experiment was successful. I believe if a bigger microwave was used and a bigger plate was used, it would give room for more circles to form on the plate, so more measurements could be taken and perhaps averaged out. It would also be another idea to test out different materials and see which ones form circles with the clearest margins, so the measurements can be the most accurate. And for references, I used the slides from class on electromagnetism. Thank you.